In chapter 10, we're going to turn our attention to circles. So we've discussed triangles, we've discussed other types of polygons, and now today we're going to start our discussions on circles. Okay, and so the first lesson we're going to talk about tangents of a circle and properties of tangents. All right. So first of all, what is a circle? I think this is kind of an elementary idea, but still something that we need to discuss as we get rolling here in the chapter. Give me 1 second here. There we go. So what is a circle? A circle is very simply the set of all points in a plane that are equidistant from a given point. Namely, what we call that point is the center point. So in other words, here's the center of our circle. There's the center of our circle. Every single point on the circle are the same distance away from that point. Okay? And so that's what we mean when we say all the points equidistant from a given point. Okay? The center of a circle is the point from which all points are equidistant. Okay, I kind of just mentioned that in the first part there. And again, there's a lot of vocab here to start. It's going to be a common theme throughout the chapter, really, because these are all pretty new ideas for all of you. So a radius, something you should already know. Okay, a radius is very simply a segment from the center of a circle to any point on the circle. So in other words, here's my center point. That segment right there is a radius. Okay, this would also be considered a radius of the same circle. All right, and so on and so forth. Each circle has infinitely many radii. Okay, or radiuses, however you want to say the plural of a radius. All right, so as we keep plugging away here, a chord. Now this is definitely something new. A chord is a segment whose endpoints are on a circle. Okay, so in other words, here's one point, there's another point. When I connect them, that's a chord. Okay, or if I connect this point and this point, that's a chord. All right, and so on and so forth. And again, in any circle, there are infinitely many chords. Okay, you're just going through and you're just connecting any points, any 2 points that lie on the circle, and those are all what are called chords. Okay, and finally, the special type of chord. There's one chord that is unique, and that is the diameter. Okay, the diameter is a chord that goes through the center of the circle. Okay, and again, there are still infinitely many diameters. Okay, but so I could draw this diameter, or maybe I draw this diameter, so on and so forth. You get the idea. Okay. That was a little bit inaccurate there. Make that center point a little bit bigger. So you get the idea. Okay, diameter, I think you already knew that, is a chord that passes through the center point of the circle. All right, a secant is very simply a line that intersects a circle in 2 points. So now it's remember, a chord is a segment. A secant is a line. So in other words, there's a line passes through that circle in 2 points. Here's another line passes through the circle in 2 points. All right, another line passes through. You get the idea. Okay, so it just hits the circle in 2 different points, and that's all that a secant line is. And really, where our discussion is going to be today is involving tangent lines. Okay, a tangent is a line that intersects at exactly 1 point. So in other words, it's off to the side here, and it just barely touches that circle right there. Okay, or maybe it's down here and it barely touches that circle right there at that point, or over here and it barely touches right there. All right, at this point. So those are tangent lines, and again, that's where our discussion is going to lie today. All right, so I think I skipped over the first example. Is it down at the bottom here? Yeah, there it is. Okay, so it says tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, or a secant, or a tangent of circle C. So if I look at segment BC, here's B, here's C, so I'm looking at this segment. That segment goes from the center point to a point on the circle. It's a radius. Okay. EA, take a look at EA here. So EA is this guy here. So here's E, here's A, and it's the line. So we're looking at this line right here. Well, again, it's a line. It crosses at 2 points, A and looks like F there. So line EA, since it crosses at 2 points, is a secant. Okay. Ray DE. Let's go ahead and erase this so that we can kind of clarify what we're looking at here. So ray DE, here's D, here's E, and I'm looking at this ray. Well, it looks to me like it touches the circle at point B, and since it only touches the circle at exactly one point, we would call that a tangent, okay, or a tangent line, if you want to be more specific. Okay, so again, that's just kind of getting comfortable with this idea of a chord, a radius, diameter, blah, blah, blah. All right, use the diagram to find the given length. So the radius of circle A, well, it's obviously, if it's circle A, that means A is the center point. So here's point A. So the circle A is obviously going to be, whoops, that smaller circle there. Didn't do a very good job there tracing. So anyway, very simply put, a radius is the distance from the center to any point. So it's easier. It's going to be easiest if we just go straight down from point A, 1, 2, to that point. So obviously the radius of circle A is just going to be 2. Diameter of circle A, the relationship between the radius and diameter is always 2 times your radius. So if the radius is 2, the diameter has to be 4. Okay. If I look at the radius of circle B now, okay, so now we're turning our attention to the big one. We just start at B. We got to go to the right. 1, 2, 3, 4 units. Therefore, the radius of circle B is 4, which makes the diameter 8. Just multiply by 2. Pretty simple idea. I think you guys understand that. All right, so now we're going to turn our attention down here to, it says tell how many common tangents the circles have and draw them. So in other words, how many different lines can you draw that are going to touch both circles at only one point? Okay, so in part A here, in other words, what you're looking at is, I could draw a line that goes here that touches that circle there, and that one just there. So that's one tangent. Okay, I got another one coming this way. All right, and actually I have a third one here since it appears as though these two circles intersect at one point there. So I could just draw one that goes straight through. So I have 3 tangents there. Okay. And again, this is just something that you'll see for part B. You have 1, 2. There's no other tangent lines you can draw. For C, there's only one. You can only go right there because that's the only line that you can draw that's going to intersect the circles at 2 different points. Okay. For E, we can kind of go on an angle here. We can go on an angle there, and then we can also go on the interior. Okay. So there's actually 1, 2, 3, 4. In that particular one. So, understand if I give you 2 sets of circles, it could have 3 tangent lines, it could have 2 tangent lines, it could have 1, could have 4, could have none. Part D has none. Those circles don't intersect at all. There's no way for me to draw a line that intersects both circles at one point. Okay, so this is a unique theorem and one that we're actually going to use quite a bit in this section. It says that in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. In other words, if this line is tangent, line M is tangent to the circle, then when I draw in this radius, it's got to be perpendicular. Okay, and that's all it's saying. So if we look here, it says in each diagram, RS is a radius and S is ST tangent. So in other words, the question is, since we know that RS is a radius, right? That's a radius. If ST is tangent, then that means this has to be a right angle. Well, how can I determine if that's a right angle? Very simply, if you look at the figure there that I just drew, it's a right triangle. Okay, so in other words, I shouldn't say it's a right triangle. I need to know if that's a right triangle, and I know it's a right triangle based on whether or not the Pythagorean theorem works. Okay, so now you'll look here and it says, all right, that's 10. That's 24. One thing to recognize here is that this piece is 26. We know this piece has to be 10 because that's a radius. So what you have here is you have 10 squared plus 24 squared equals, and then the third piece there is 36 squared. And so as I simplify this out, I get 100 plus 576 equals, and then I have 36 times 36, which is 1296, and I'm checking to see if that's accurate. Obviously 100 and 576 does not equal, therefore ST is not tangent. So here we would just say no, it's not tangent. Okay, part B, again, same idea. Okay, this is 5, this is 12, that's 8, this much left is 5, so you have 5 squared plus 12 squared equals 13 squared. And if you remember from the Pythagorean triples, you're going to recognize that this is actually a Pythagorean triple. Therefore, without doing much work, you know that yes, it's got to be tangent. Okay, and you guys can look at part C on your own here, just to verify that you have an idea as to what's going on. It says in the diagram, B is a point of tangency. Find the radius of circle C. So again, if I know that AB is tangent, then I know that this has to be a right angle. Okay, they're telling me it's tangent. And so now what you have is you have the Pythagorean theorem, right? R squared 77 squared equals, screwed up there, rewrite that, equals, and then I have 49 plus R quantity squared. Okay, now this is not going to be the easiest thing to solve, because there's actually some things that you got to do here. You have R squared plus 5929 equals, and then you got to FOIL this thing out. Okay, so when you FOIL this out, and off to the side, maybe you want to write, maybe you want to do 49 plus R, that's fine, but long story short, you're going to end up at 2401 plus 98R plus R squared. Okay, pull everything to one side, minus your R squared from both sides. Cancel. Well, that worked out well. Okay, so now really what I'm looking at is I have this equation. I want to solve for this R, so I got to subtract 2401 from both sides. So I have 5929 minus 2401. I get 3528 equals 98R. Divide both sides by 98, and you get R equals 36. So again, not the most straightforward, okay, but setting it up is pretty simple. It's just solving that gets most people. So part B, go ahead and take a few moments right now, maybe hit pause and work through that example and make sure you got it. The last theorem that we're going to look at in this section says if you have two tangents that come from the same external point, then they have to be congruent. All right, in other words, simply put, if you look at example 6, since they tell you that QS and QR are both tangent, so that and that are both tangent, then this guy and that guy have to be the same. So, 3x plus 5 has to equal 32. All right, now you just go through your simple algebra skills. All right, divide both sides by 3, x equals 9. All right, and you're done there. So again, you guys can look at example 7 on your own. Same idea, same principle. Shouldn't be too difficult for you. So again, as we go through chapter 10, we're going to continue discussions on some new ideas that are probably foreign to you. So again, I encourage you to keep up with the videos, take solid notes, and as we go over in class, ask any questions that you have and make sure you get them answered.